Ladies and gentlemen, today, exponential recursion. Okay? You may be familiar with these in terms of what's called geometric sequences. And that's where when we go from one term to the next, we're multiplying by some constant value. We're continuously multiplying. So we're going to be dealing with scenarios similar to what we have here on the board. A tennis ball, when it's taken out of a brand new pressurized can, has a 55% rebound percentage. That means when you drop it, it bounces up 55% of where it started. So what we need to be able to do is write an explicit function rule and a recursive rule if we know the starting height of that tennis ball. So my problem here, the 55% rebound percentage, if the ball is dropped from 20 meters, then write that recursive rule and explicit function rule on how high it will be after it bounces several times. So our recursive rule for reference, m sub n plus 1 equals m sub n times r. This should look very familiar because of the linear recursion lesson, except this time we're multiplying by some common value. The explicit function rule, m sub n equals the initial value, m sub 0, times r to the exponent of n. Again, some of this stuff might not be familiar to you, so in terms of this problem, let's do some defining. R is the common ratio. N is the number of bounces. And m sub n is the final height after n bounces. So common ratio. If I look at the common ratio, I know that my percentage is 55%, so I'm going to continuously be bouncing 55% from where I first began. So that means my common ratio here is 0.55. That is my common ratio. Once I identify the common ratio and my initial value of 20, that means m sub 0 is 20 meters. Once I've identified those couple of things, I can then write both the recursive rule and the explicit function rule. The recursive rule is the easiest. Again, this is the next term. This is the current. And I have m sub n plus 1 equals m sub n times 0.55. Only thing we change here is the common ratio. Just like the only thing we changed earlier was the common difference. The recursive rule, m sub n plus 1 equals m sub n times 0.55. The explicit function rule. This is the term we're trying to find. M sub 0 is the initial. Where do we start? M sub 0, initial. Where do we start? And R is the common ratio. So we're trying to find m sub n, and we know we start at 20 meters, and then we multiply that by our common ratio to the nth power. A power that tells us that's how many bounces it takes. And that is exponential recursion.